Hi! If you haven't watched the previous 4 videos of our series that explain basic add and get operations of TRIADB database framework, you might find it a bit difficult to understand how this hypergraph was created and how traversal operations work under the hood. Nevertheless, I will make an attempt to assume that this is the first video you watch. First, let's decipher this hypergraph you see here. Recall that a hypergraph is a generalization of a graph in which an edge can join any number of vertices. According to hypergraph terminology, these edges are called hyperedges and are drawn here with a red color. To differentiate their type, we also call them hyperbones. And the yellow nodes that are connected to each hyperedge are called hypernodes or hyperatoms. Each set of hypernodes with a hyperedge visually represent a table record. There are 7 records from 3 tables shown on this graph, 2 on the left, 3 in the center, and another 2 on the right. For those of you familiar with entity relationship diagrams, this is a classic many-to-many relationship of a parts entity with a supplier's entity, and the catalog table plays the role of associative entity between the two. In the relational data model, this SQL query joins 15 columns from the 3 tables into a single view, and the result set includes all the records ordered by the supplier ID and supplier name. If we filter this record set by the part name Acme widget washer, we get back 3 records only. But in fact, this is a combined view of 2 part records with 3 catalog records and another 2 supplier records. The main difference with the graph representation is that all values are deduplicated. Let me explain it again. There is a silver or red Acme widget washer, which is manufactured by these 2 suppliers from Nottingham and Illinois. And our price catalog has 3 entries. Two for the USA supplier and 1 for the UK supplier. From a graph traversal point of view, we start from the part node with the label Acme widget washer that it has 2 color variants, silver and red. From the part neighborhood, we move through the shared part IDs to the 3 catalog hyperbones. And from these nodes, we pass through the common supplier ID in the supplier neighborhood. This is exactly the route we're going to demonstrate next. But before we start, you should become aware of the semantics behind the scene. This is exactly the same graph as before. The only difference is that values have been replaced by numerical key references with 2 dimensions. One dimension is used for the entity or attribute. The other is used to represent an instance of them. This is a major difference from other graph data models because traversal and queries are not based on any namespace. Now we begin command execution in Python Jupyter Interactive environment. Click on kernel, restart and clear output, all output. Connect TRIADB framework object to InterSystems cache server and create two objects to access hyperbonds and hyperatoms. Then we search for the node with the label Acme widget washer and retrieve its reference key. We can start our HyperGraph exploration. First, we find the two-part hyperbonds. We can view these records with references or with values. Then we convert these into attribute sets. Part IDs, part colors, part weight, and part units. There is a cleansing problem here. To visualize this subgraph, we also get the bidirectional links between hyperbonds and hyperatoms. And we use GraphViz to get this graph layout or this graph layout. And we continue our HyperGraph traversal. We use these two shared part IDs to access the three catalog hyperbonds. Like before, we can view catalog tuples with values, and we can convert them to hyperatom collections. Two-part IDs, three catalog checks, two catalog quantities, two catalog prices, two catalog dates, and two supplier IDs. These last two items are shared between catalog and supplier hyperbonds. We use the second to retrieve supplier tuples. And the corresponding hyperatom collections. The procedure to visualize the hypergraph in which we started our demo is now repeated. But this time we use Vue.js JavaScript library to create an interactive visualization on HTML canvas. And we redraw to obtain the same graph with key references instead of values. And this concludes the last video of our TRIADB supplier part catalog YouTube playlist. Thank you so much for watching. Your feedback is valuable for us, so please leave your comments below and hope you visit our channel again for another demo.